Question 35, Electronics and Communication Engineering, GATE 2018. For the circuit given in the figure, the voltage VC in volts across the capacitor is dash. 4 options are given to us. We need to find out the voltage of capacitor in the circuit. For a detailed lecture on the basic concepts, please refer to the NPTEL video, Lecture 3, Circuit Elements Part 1, Basic Electrical Circuits by Professor Ankush Sharma, Department of Electrical Engineering, IIT Kanpur. Let's first see the basic laws in order to solve this problem. According to Ohm's law, when the temperature is constant, the voltage across a pair of nodes is directly proportional to the currents that is flowing through it. Therefore, in order to replace this proportionality constant, we can introduce a numerical constant called resistance. Therefore, if we have a component across this pair of nodes, the voltage across this resistor is equal to the current that is flowing through it times the value of this resistance. This is Ohm's law. Let's make use of this law in order to solve this problem. Here a AC voltage of 5 sin 5t is appearing across this pair of nodes. So this is the voltage supplier of this circuit. We are asked to find out the voltage that appears across the capacitor here. So in order to find that, let us first calculate the impedance of this circuit, and then using this we can find out the current that is flowing through this circuit. Next, the value of the voltage across the capacitor will be the current flowing into this loop times the value of the capacitive reactance. So let's first find out the value of total impedance of this circuit. The value of total impedance will be 100 kilo ohm plus 1 divided by J into omega C plus 100 kilo ohm. The value of the angular frequency is given as 5 radian per second. According to this voltage source, we can just take the value of omega, and the value of the capacitance is given as 1 microfarad. Therefore, the value of the total impedance will be 200,000 plus 1 divided by 5J, and this is in micros. Therefore, this will be 1000 into 10 to the power of 3 into 10 to the power minus 6J plus 1 divided by 5 into 10 to the power minus 6J. This is equal to 1 plus J divided by 5J mega ohm. Let's find out the value of the total impedance in polar form, so that we can do the value of multiplications and divisions just by addition and subtraction. The value of the total impedance will be this is equal to square root of 2 angle 45 degree divided by 5 angle 90 degree. Hence, the value of total impedance will be 0.2828 angle minus 45 degrees mega ohm. So therefore, the value of the current that is passing through this circuit will be the voltage across it divided by the total impedance. The voltage across it is given as 5 sin 5t, and the total impedance is now calculated as 0.28 angle minus 45 degree. Let's convert this in terms of polar form. The phase angle of this is equal to 0 degrees from sine axis. So this is the cos axis, this is the minus sine axis, this is the minus cos axis, and this one is the sine axis. So the angle lies over here. In order to convert it into polar form, let's have it in cos terms in a standard way. Therefore, this will become minus 90 degrees. Therefore, 5 sin 5t can be written as 5 angle minus 90 degrees divided by 0.28 angle minus 45 degree. The total current will be 17.85 angle minus 45 degrees microampere. Now let us find out the value of the voltage across the capacitor, which is equal to the current passing through the capacitor, which is same as the total current, times the capacitive reactance. This is equal to 17.85 angle minus 45 degrees times the capacitive reactance is 1 divided by 5 into 10 power minus 6 J. This is equal to 17.85 angle minus 45 degrees divided by pi angle 90 degrees. This is in microampere and this is in microvolt. So these two will be cancelled. The voltage across the capacitor will be 3.57 angle minus 135 degree volt. If we observe, the options are mentioned in standard notation, which is the peak voltage sin omega t plus or minus 5, where this is the phase angle and this is the angular frequency and this one is the peak voltage. Let us denote the value of Vc that we got in terms of standard form. Let us first convert these options into polar form and then find out the right option. The value that we got is same as 3.57 cos phi t minus 135 degree. We want the answers in terms of sine, so we can call this as 3.57 sine phi t minus 45 degree. So, comparing the options, we can say that option C is the right answer. The answer is option C. Thank you.